Let's take a look in chapter 2. So yeah, chapter 1 we were just looking at just working with the whole numbers, 0, 1, 2, 3. So now we're throwing in the negative numbers. And yeah, we're focusing just on integers, so no fractions or decimals yet. Alright, so these are the integers on the number line. Yeah, if you're to the right of 0, you're positive. If you're to the left of 0, you're negative, and your number has a negative sign, a minus sign out front. So the first idea we look at is absolute value. And absolute value just means the positive part of any number. It has this notation, so 2 vertical lines on each side. And another name is the magnitude. Alright, so this is a simple idea. So the absolute value of negative 9 is 9. The absolute value of 3 is 3. The absolute value of 0 is 0. Alright, so just remember, yeah, the absolute value, it always comes out, the smallest it can be is 0. It's usually positive for any, it is positive for any positive numbers. Yeah, another way to think about it is it's the distance of the number to 0. So the absolute value of negative 2, you can think of it as the distance, how far do you have to go to get from negative 2 to 0. Well, it's a distance, a positive distance of 2 units. Some examples of that. Find 2 numbers with absolute value equal to 98. Well, the absolute value of 98 is 98. And if you look at negative 98, that has the same absolute value. Okay, so there are exactly 2 numbers that have the absolute value we're looking for, 98 and negative 98. But this one, yeah, it's more like a trick question. Find a number with absolute value equal to negative 2. Well, absolute value is always positive or 0, so yeah, there's no way to get absolute value negative 2. Okay, next we look at inequalities. Okay, so now we're comparing 2 numbers, and the main idea is we're looking at which numbers to the left and which numbers to the right. Okay, so left and right are important ideas on the number line. This symbol, this is the less than symbol. Okay, so you can see the small end is on the left, it widens out on the right, so we use this symbol when the first number, the number on the left, is less than the number on the right. And what does less than mean? Less than means to the left on the number line. And so for example, example 1, 1 is less than 3. And that's saying 1 is to the left of 3 on the number line. So this is true. Example 2, does this make sense? Negative 2 is less than 1. Isn't 2 bigger than 1? Well, here's negative 2, and it is to the left of 1. So this is true. Also, negative 3 is less than 0, and negative 3 is to the left of 0. This last one, yeah, this looks fishy. Is 1 less than negative 2? Is 1 to the left of negative 2? No. 1 is to the right of negative 2. So this is false. All right, so any inequality like this, yeah, it's either true or false. And this one's false. Okay, so yeah, another simple idea. You're just checking left and right. And yeah, this symbol means a strict inequality, so negative 2 less than negative 2, that's also false. Negative 2 is not to the left of itself. Yeah, sometimes you see the less than or equal to symbol. So yeah, if there was a line under here, then this would be true, but we're not allowing equality if it's just this less than symbol. All right, so this is less than, it means to the left. Of course, you could turn it around and look at greater than. So this is the greater than symbol. This means the first number is to the right of the second number. So 2 is to the right of 1. Yeah, that's true. 1 is to the right of negative 2. Yep. Now here's 1. Here's negative 2. Yet 1 is on the 1 is to the right of negative 2. Yeah, we saw 1 to the left of negative 2 is false, but 1 to the right of negative 2 is true. Yeah, here's one where it's easy to make a mistake. Is negative 2 to the right of negative 3? Let's check on the number line. Negative 2, yeah, it is to the right of negative 3. And negative 3 to the right of 2, yeah, that's definitely false. So negative 3 is to the left of 0, 2 is to the right of 0, so the correct statement here would be the less than. So negative 3 is less than 2. Well, this way around is false. Yeah, you sometimes see these types of questions. So if I give you these two numbers, 5 and negative 7, what's the correct inequality symbol? So is 5 to the left of negative 7, or is 5 to the right? Yeah, so 5 is to the right of negative 7, so you need one of these. So this is true. All right, so left and right on the number line. So this is warming us up for this section. So now adding sign numbers. So on the number line, a nice way to think about adding sign numbers is like this. So we saw this already in chapter 1. You're moving to the right when you add a positive number. But if you add a negative number, then you're moving to the left. Okay, left and right. So this is the main idea. And move to the right when you add a positive number, but move to the left when you add a negative number. We'll see this is, so adding a negative number, we'll see it's the same as subtracting. Okay, so you're going left. An example, let's add these two sign numbers, -2 plus 5. All right, so we're starting here on the number line, and then just move 5 units to the right. We end up with 3. Okay, so -2 plus 5 is equal to 3. Yeah, so I just use these parentheses just to kind of emphasize the two numbers. But we don't really need them here. This question could look like this, just -2 plus 5. Okay, another example, -2 plus -1. Okay, so this time we're adding a negative number, so we have to move to the left. Okay, we're starting at -2 again, and this time moving to the left 1 unit. We end up at -3. So -2 plus -1 is equal to -3. Yeah, we can drop these parentheses around the -2, but we need to keep them. We can't drop these parentheses. Yeah, you never want to have a plus and a minus together. And so this is -2 plus this negative number, -1, that's equal to -3. All right, more examples in the book. All right, so again, move to the right when you're adding positive, move to the left when you're adding a negative. So adding -3 goes this way. Here's -3 plus 2, so starting at -3, adding 2, you get to -1. And yeah, they're making the point here that -3 plus 2 is the same as 2 plus -3. You end up at the same place. So yeah, you always expect addition to be commutative. If you add two numbers of any signs, the order doesn't matter. All right, yeah, so it's not practical to use the number line, especially for bigger numbers, so we need a rule. Okay, so here's the rule for adding two sign numbers. we've got case A and case B. So the easy case, if the two numbers have the same sign, so both positive or both negative, then you just add the absolute values and keep the sign. Alright, so that makes sense on the number line. If you're adding two positive numbers, that's easy. The answer is positive. But if you're adding two negative numbers, so start at the first negative number and then move left, the answer will definitely be negative. And the number part is just going to be, you're just really adding the two absolute values. The trickier case is case B here. If you're adding two numbers with different signs, so positive and a negative, or a negative and a positive. In fact, in that case, you're really subtracting the absolute values. And the sign of the answer, well, it depends on which number has the bigger absolute value. So if the absolute value of the positive number is bigger, the answer will be positive. If the absolute value of the negative number is bigger, the answer is negative. And so it's like a tug of war. One number is going to dominate and push you to the left or the right past zero. Okay, and when you write down this rule, it does look a bit complicated. So we need to practice. Example 1. So here we have negative 13 plus negative 12. Okay, so just to check everything here, so the operation is addition. So this rule is only for addition. Our two numbers are both negative. So we're in case A. We have two numbers with the same sign. The rule is work out their absolute values. So the absolute values are 13 and 12. Add those absolute values, that's 25, and keep the negative sign. So the answer is negative 25. And double check that makes sense on the number line. So you're starting at negative 12, and you move another 13 units to the left. You can see you're getting to negative 25. Example 2, so here we have two numbers with different signs, so we're in case B. Okay, we have to work out the absolute values, 16 and 13, those are the positive parts. And right away we can see the negative number has the larger absolute value, so the whole answer is going to be negative. We have to use the sign of the number with the bigger absolute value, so the answer will be negative. And in case B, we subtract. So it's 16 minus 13, that's 3. And we give it that negative sign, so the answer is negative 3. So there's like 3 or 4 steps here. So again, we were in this case B situation. We had two numbers with different signs. First, work out their absolute values. We're subtracting, so subtract the smaller absolute value from the larger. So we had 16 minus 3, 16 minus 13 was 3. And we have to use the sign of the number with the larger absolute value. So we use the sign of the negative 16, that was negative. Yeah, again, for notation, I asked this question with parentheses, but it's the same question without parentheses. So this is negative 16 plus 13. The answer is still negative 3. Yeah, in the book, the rules are the same. Here, this example, we have 15 plus negative 18. We're adding two numbers with different signs. So yeah, this is very similar. So the absolute values are 18 and 15. Subtract the smaller to get 3. And the negative 18 was larger, so the answer is negative. Here we have two with the same sign. So add the absolute values. That's 16. Keep the sign. That's negative 16. Yeah, another example. Yeah, this time we have negative 36 and 49. The absolute values are 36 and 49. Different signs, so the answer is this. We need a subtraction. This time the positive number has the bigger absolute value, so the answer is positive. We have 49 minus 36, that's 13. So this time the answer is positive 13. The helpful way to think about these positives and negatives is using money. Okay, positive numbers, that's the good money. That's money that you get paid. Negative numbers, that corresponds to money that you have to pay. Okay, so money coming in, money going out. Example: suppose you have $90 in your wallet. You also have a phone bill for $35 and a paycheck for $65. Add these amounts to find out how much money you have. Okay, so just here we're thinking, yeah, this 90, that's money you have. The 65, that's a paycheck, so that's also positive. But the phone bill, that's going to count negative. So the addition is, yeah, the positive 90, you're adding negative 35 for the bill, plus 65 for the paycheck. All right, so here we're adding three things, but we go from left to right, so do this addition first. So 90 plus negative 35. Yeah, that's a case B situation. Subtract the absolute values to get 55, and the answer is going to be positive since this is positive. then do the second addition. So then it's that 55 plus 65. Okay, that's easier. That's just 120. So the amount of money you have. So when you take care of the phone bill, you'll be left with $120. So that's your net worth. Okay, one more idea. We'll leave this in the next section. The opposite of a number, to get the opposite of a number, just switch its sign. So another easy idea. So the opposite of 17 is negative 17. The opposite of a negative number is positive. So the opposite of negative 456 is 456. The opposite of 0, yeah, negative 0, that's the same as 0. So yeah, there's exactly one number that's equal to its opposite, that's 0. Yeah, maybe it's confusing. So the opposite of a number, that's a different idea from absolute value. So absolute value is always the positive part of the number. The opposite of a number could be negative. And yes, then it gets a bit confusing in the notation. Yes, so we use the minus sign for subtraction, but we also use it for this idea of opposites. So if you start with 10, the opposite of 10 is negative 10. So every time you see a minus sign like this, you could think of it means the opposite. So you could read this as the opposite of 10 is negative 10. Here, if we start with negative 10, so this whole thing means the opposite of negative 10. Well, the opposite of negative 10 is 10. So we get this equation. So this is saying the opposite of negative 10 is 10. That's a good way to read it. Okay, you could also, yeah, if you think of this, if you say start with 10, yeah, the opposite of 10, you could also read this, the opposite of 10 is 10, you get back to the start. All right, yeah, maybe don't do that. Another example, yeah, so this in words, how would you read this? It's the opposite of negative 49, and that's equal to 49. So if you switch the sign on negative 49, you get 49. All right, so the main thing to realize here is, yeah, whenever you have this situation, two negatives like this, yeah, it's like they cancel. The opposite of the opposite, it's just saying, yeah, the opposite of a negative number is positive, so you lose the sign. Yeah, last comment here. If you add a number to its opposite, you always get 0. Why is that true? Yeah, it's a case B situation. So if you add a number to its opposite, yeah, you're adding two numbers with different signs. The opposite of a number is going to have the same absolute value. So you're subtracting a number from itself, you get 0. So the answer will always be 0. So here, if start with 49, add its opposite, yeah, you get 0. Start with negative 13, add its opposite, you get 0. Okay, yeah, so just if you're adding a number to its opposite, yeah, you always get 0. Here I'm thinking of negative 38. This is the opposite of negative 38. It's plus 38 if you want, but you'll definitely get 0. All right, so yes, I take a look at, you can start homework 3. Try these questions. Okay.